So just to give a feel, what's summary all about? You've got a set of data, but you want to be able to say something about that data. It's no good just kind of plotting the data, or you want to draw some conclusions about it. And the first step to doing that is to summarise the data. So you can either do this numerically, and I'm sure you've all come across the mean, which is the average of a set of data. So this is just a data set that I'll look at a few times this morning, taken from some newborn calves, well, fairly young calves, and the cases developed a certain disease. There's 15 of those, and there's normal calves, 173, who didn't develop the disease, and various measurements were made on them. And so this was white blood cell count, and you can see with the mean it's a lot lower in the cases than the normals. So these are summary statistics for that data. An alternative way of getting a measure of the central location is by taking the median, which is the middle value. We'll look at that a bit more later. Another thing you want to do is to say, well, how accurate is that mean? If I took another 15 calves who were cases, would I get this mean again, or would I get something a bit different? Well, you probably can see straight away you would get something different, but you want to know how different it would be. And this standard error is a measure of how different a second mean would be. So you would expect a second mean to differ on average by 0.44 from this mean of 2.67. So it's reasonably accurate. And then you've got quite a small standard error for the mean for the normal calves as well. So yeah, you can do it by numerically. Sometimes, depending on your audience, what you're sort of, who you're presenting to, whether it's a publication or a poster or an oral presentation, you might want to do it in graphical form. This makes it far more obvious to people if you've got a point to make or a conclusion to be drawn. So you could just put those means in a bar chart, and here, given the value of the mean, sometimes people would add the standard errors to those means, sort of, so you'd put plus or minus 0.44 up as a kind of bar above here. So there's lots of options for presentation. Whereas over here we've got something summarising the distribution of the data, and it's actually called, I'll look at it again, but it's called a Box-and-Whisker Plot. So this one plots the median in the middle, and then it's got this block here which summarises the middle 50% of the data, so the middle half of the data. So this point here, the top point, is the point above which a quarter, 25% of the data lie, and the bottom point of this red bar, 25% of the data lie below that, and then the minimum and the maximum are also plotted. So you visually just get an idea of what the distributions of the cases and the normals were, because you don't completely get that from just looking at means and standard errors and medians. Lots of different ways you can actually summarise the data. How you summarise it depends on the type of data, so it's worth just, it'll probably be obvious to you that there's different types of data that you can get, but it's worth just running through what the different types are. If you've got measurements, something like white blood cell count that we've just seen, or blood pressure, temperature, which are all measured on a scale and you get a number, we could describe these as continuous variables, continuous data. And so there's specific ways we would summarise and analyse that sort of data. Another type is binary data. So these are data where something either happens or it doesn't happen. So there's just two different options. So it might be success or failure of a treatment. If you're looking at survival, an animal might be alive or dead. So you've only got two different options. It doesn't matter how you code the data, whether it's a sort of 0, 1 or in words, and that's binary data. So that affects how it's summarised and analysed. Something called ordinal categorical data is where you've got categories, but they're in a certain order. So if you have a disease and you measure it as mild, moderate or severe, that would be defined as an ordinal category. It's categorical, but you do want to take into account the fact that it's ordered as well. And less commonly, in fact, you can have non-ordered categories where there's something like the colour of an animal's fur. There probably wouldn't be a specific ordering of that. Would then need to be taken into account, certainly in how you do your statistical analysis of the data. I want to mention another type of data because it's often, if you do come across this type of data, people often don't summarise it correctly. It's occasionally you'll be measuring the time to an event. If, for example, you're looking at survival of an animal or the time, it's basically the time, whenever you're looking at the time to something that may happen, and the key thing is that sometimes it may not happen. So if you're waiting for an animal to develop an infection, you've got lots of times when the animal's developed the infection, and you've got a group of animals that didn't develop it at all by a certain time point. And so that is sometimes called survival data, even if it's not survival that you're measuring, and that needs special care when you come to think about how to summarise it.